Students, today's class we are going to learn the determinant of a square matrix. In the previous class we discussed about determinant of a 2 by 2 square matrix. In this class we are going to learn generalized square matrix. Okay. Next, today's class we are going to learn the topics minor and cofactor of an element. Definition of minor and cofactor of an element. Next, determinant of a square matrix. Next, problems. Okay. So first, minor of an element. In a square matrix, the minor of an element is the determinant of the matrix obtained by deleting the row and column of that element. Okay. The determinant of the matrix obtained by deleting the row and column of that element. Minor is defined for every element. For any element, minor is defined as we have to remove the column and row of that element. Remaining matrix determinant is called minor of element. For example, suppose A11, A12, A13, A21, A22, A23, A31, A32, A33 is the matrix, 3 by 3 matrix. Suppose A13, I am taking minor of this element. To find out minor of this element, we have to remove this, delete this row and column. Remaining matrix, its determinant A21, A22, A31, A32. It is 2 by 2 matrix and its determinant AD minus BC, that is A21 into A32 minus A22 into A31. It is the minor of that element A13 and it is denoted by M13 notation. A13 minor is M13. Okay. For example, determinant of A31, this element, a minor of that element. Minor of that element is we have to remove the row and column of that element. ఆ ఎలిమెంట్ ఉన్న రోని కాలంని రిమూవ్ చేయాలి. రిమైనింగ్ రిజల్టెంట్ మ్యాట్రిక్స్ యొక్క డిటర్మినెంట్, that is A12, A13, A22, A23. It is notation M31. And what is the AD minus BC? Determinant of 2 by 2 matrix A12 into A23 minus A13 into A22. It is determinant minor of A31. Next, for example, minor of A22, this element. We have to remove the row and column, delete the row and column. Remaining resultant matrix A11, A13, A31, A33. Its determinant means AD minus BC A11, A33 minus A13 into A31. It is A22 minor is M22. It is this one. Okay. Removing the row and column of that element, resultant matrix determinant is called a minor of that element. Here 9 elements are there. We have 9 minors. It is denoted by MIJ. Next, it is minor. For example, capital A equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Minor of 4. Minor of 4 means we have to remove the row and column, delete row and column. Resultant matrix, remaining matrix 2, 3, 8, 9. Its determinant 2 by 2 matrix, 2 into 9, 18 minus 8 into 3, 24. 18 minus 24 means minus 6. It is minor of 4. For example, next, minor of 3. Minor of this 3 element. Minor of 3 means we have to remove, delete this row and column. Remaining resultant matrix, determinant 4, 5, 7, 8. So determinant AD minus BC 4 into 8, 32 minus 7 into 5, 35. 32 minus 35 means minus 3. Next, determinant of 9, minor of 9. Minor of 9 means we have to remove the row the element contains and column. Resultant matrix 1, 2, 4, 5 determinant. 1 into 5, 5 minus 2 into 4, 8, 5 minus 8 minus 3. This is minor of an element. Minor of element means we have to remove the row and column of that element. Remaining resultant matrix determinant is called the minor of that element. Okay. Next, cofactor. Cofactor of an element. Cofactor of an element Aij is denoted by capital Aij, that equal to minus 1 whole to the power of I plus j into mij. Mij means minor. Minor of small aij element. Minor ni minus 1 whole to the power of I plus j. If you multiply with minus 1 whole to the power of I plus j, then the value is called cofactor of that element, where I is row position and j is column position of that element. Suppose if you take A23 element, cofactor of that A23 element is capital A23, capital A23. If you take A23 elements, its cofactor is capital A23, and it is defined as it's minus 1 whole to the power of A row lo undi the second row third column, means 2 plus 3, minus 1 whole to the power of 2 plus 3 into its minor m23 minor value ni minus 1 whole to the power of 2 plus 3 to multiply this, where we will get cofactor of A23 element. Okay. In general, minor mij is multiplied with minus 1 whole to the power of I plus j. The I is the row position, j is the column position. For example, capital A equal to matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. Then cofactor of A11. I am taking first one, cofactor of A11 equal to, that is denoted by capital A11, that is minus 1 whole to the power of I plus j, means it is first row, first column, so minus 1 whole to the power of 1 plus 1 into its minor m11. Minus 1 whole to the power of 1 plus 1 means minus 1 whole square. Minus means we have to delete row and column. Resultant matrix determinant A22, A23, A32, A33. So this minus this one, AD minus BC. Minus 1 whole square means plus 1, A22, A33 minus A23, A32. That is the suppose. For example, next example, cofactor of an element A23. A23 means capital A23, it is denoted by minus 1 whole to the power of 2 plus 3, second row, third column, into its minor. Minus 1 whole to the power of 2 plus 3 means minus 1 whole to the power of 5. M23 means minor, we have to delete row and column. Remaining matrix A11, A12, A31, A32. So AD minus this is BC. Determinant minus 1 whole to the power of 5 means minus of determinant of A11, A12, A31, A32. Only this minus 1 whole to the power of I plus j means plus 1 or minus 1 will come. Multiply minus with plus or minus 1. Next example. A equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Then cofactor of this 5. Cofactor of 5 equal to minus 1 whole to the power of second row, second column lo undi. So minus 1 whole to the power of 2 plus 2 into its minor. How to delete 1, 3, 7, 9. So minus 1 whole to the power of 4, 1 into 9 minus 7 into 3, 9 minus 21. Minus 1 whole to the power of 4 means plus 1. 9 minus 21 means 12. 1 into 12, 2. Next example. Cofactor of 4. This 4. So minus 1 whole to the power of second row, first column, 2 plus 1 into its minor. Delete row and column. 2, 3, 8, 9. Minus 1 whole to the power of 2 plus 1 means minus 1 whole cube. AD minus BC. 2 into 9, 18. 3 into 8, 24. So minus 1 whole cube means minus. 18 minus 24 means minus 6. Minus of minus plus 6. It is cofactor. Means we have to multiply the minor with the value minus 1 whole to the power of I plus j. That is either it is plus 1 or minus 1. Next, determinant of a square matrix. In a square matrix, the sum of the product of the elements of any row or column with their corresponding cofactors is called determinant of the matrix. Okay, do you understand? In a square matrix A, the sum of the products of the elements of any row or column, the sum of the product of the elements of any row or column with their corresponding cofactors is called determinant of the matrix A. Means if you take any row elements, that is a11, a12, we will discuss in next example. Okay, if you take any row elements or column elements, that elements are multiplied with their cofactors, then adding the sum of the products of the elements of any row or column with their corresponding cofactors is called determinant of the matrix A. Okay. Next, we will see the examples. If suppose capital A is the matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. Determinant can be calculated by 6 ways. In what 3 by 3 matrix means we have total 3 rows. First row, second row, third row. First column, second column, third column. Total 6 ways we can find the determinant. Any row, elements of any row or column. So first I am taking first row. First row elements A11, A12, A13. Its cofactors. What are the cofactors of A11, A12, A12? Capital A11, capital A12, capital A13 are their cofactors. A11 cofactor is capital A11, A12 cofactor is capital A12, A13 cofactor is capital A13. Product, multiplication, A11 into capital A11, its product, A12 and its cofactor capital A12, A13 plus capital A13 plus addition, sum. This is the expansion by first row. Okay. A11, small a11 into capital A11, A12 into capital A12 plus A13 into capital A13. I am taking first row elements and their cofactors and sum, product of the cofactors with sum. It is called determinant of A. It is first row expansion. Suppose if you take second row expansion, what are the elements? A21, A22, A23. That is A21 into its cofactor capital A21 plus A22 into its cofactor capital A22 plus A23 into its cofactor capital A23. Their sum. It is also determinant of. Suppose if you take first column, what is the first column elements? A11, A21, A31. So A11 into its cofactor capital A11 plus A21 into its cofactor capital A21, A31 into its cofactor A31. Their sum. It is expansion by first column. It is also determinant of A. These three values are any value, any row, first row, second row, third row, and expand any row or any column, first column, second column, third column. 6 ways the answer will be same. We get same answer if we expand by first row or second row or third row or first column, second column, third column of matrix, we get the answer. This expansion is called Laplace expansion. Okay, this expansion is called a Laplace expansion. The determinant of a matrix is the product of sum of the product of the elements of any row or a column with their corresponding cofactors. Means if you take any row, generally we will take first row elements. If you take first row elements, the elements are multiplied with corresponding cofactors. Means a11 cofactor capital A11, A12 cofactor capital A12, A13 cofactor capital A13, we have to multiply small a11 into capital A11 plus A12 into capital A12, A13 into capital A13. This sum is called determinant of A. Okay. Next. Note. If A equal to capital A11, A12, A13, A21, A22, A23, A31, A32, A33. So determinant of A equal to, by the definition, A11 into, I am taking here first row, A11 into capital A11, A12 into capital A12, A13 into capital A13, cofactors. What is the A11? A11 means cofactor. What is the cofactor? Minus 1 whole to the A11 as it is, minus 1 whole to the power of 1 plus 1 M11. It is the cofactor of A11. And A12 means minus 1 whole to the power of 1 plus 2 into M12. And capital A13 value is minus 1 whole to the power of 1 plus 3 into M13. Okay, these are the cofactors. And minus 1 whole to the power of 1 plus 1 means minus 1 whole square. Minus 1 whole square means plus 1. So it is A11 into M11. Minus 1 whole to the power of 1 plus 2 means minus 1 whole cube. Minus 1 whole cube means it is a minus 1. So minus A12 into M12 plus minus 1 whole to the power of 1 plus 3 means minus 1 whole to the power of 4, that is plus A13 into M13. Means same determinant here, cofactor. Instead of cofactors, if you take it as a minus, expand it, means A11 into minor minus A12 into minor, A13 into minor. Okay, first row elements. For first row only, cofactor means minus 1 whole to the power of 5 plus j. So here we get minus 1 whole to the power of 5 plus j is plus, minus here plus. If you take second row, it is minus, it is plus, it is minus, plus, minus, plus. That elements into minus. Okay. Next, we have to remember first row. If you take first row, A11 into minor minus A12 into minor plus A13 into its minor. Next, note 2, we have to remember this one. Plus minus plus minus plus minus plus minus plus, because if you take this row, expand determinant A11 into minor minus this element A12 into minor plus A13 into minor. If you take second row, minus this element, what is this element? A21 minus A21 into M11 plus A22 into M22 minus A23 into M23. You can expand. Remember these signs. Next, third note, if the sum of the product of the elements of any row or column by the cofactors of another row or column is 0. If you take this A11, A12, A13, if you multiply same cofactors, then the determinant is resultant value is a determinant. If you multiply with another row cofactors, I am multiplying with second row cofactors A21, A22, A23, then the resultant is 0. Okay, next we will do the problems. First problem. Mainly for the determinants I am using this formula, so remember this one. Det A equal to A11, A12, A13, A21, A22, A23, A31, A32, A33. Determinant value is det A equal to A11 first row elements A11 into minor minus A12 into minor plus a13 into minor, okay, minus, here it will be minus a11 into minor minus a12 into its minor plus a13 into minor, okay, that is the, I will do the problems using that. So first, if a equal to 1 2 2 2 1 2 2 2 1, then find determinant of a. We have to remember this signs, plus minus plus. If you take first row, so first determinant of a equal to 1 into, first row I am taking 1 into its minor. Minor means we have to remove row and column 1 2 2 1, determinant value. Next, minus minus 2 into its minor, row and column is deleted, 2 2 2 1, determinant. Next, plus 2 into, remove row and column, 2 1 2 2, okay, I am taking first row elements, that's why it is plus. Second one, first one is plus, here minus, here plus. Plus 1. First row plus minus plus, that elements sign and its minus, okay, simplify. 1 into AD minus BC, 1 into 1 minus 4, minus 2 into 2 into 1 2, minus 2 into 2 4, 2 minus 4, plus 2 into 2 2 is 4, minus 2 into 1 2 4 minus 2. 1 minus 4 minus 3, minus 3 into 1 means minus 3, minus 2 into 2 minus 4 is minus 2, 4 minus 2 is 2, 2 into 2, so minus 3, minus 2 minus 2 plus 4, 2 into 2 4, 4 plus 4 8, 8 minus 3 means 5, okay, it is determinant of the matrix. This 5 is called determinant of a matrix, okay. What I will repeat, 1 into its minor, minus 2 into its minor, plus 2 into its minor, whatever may be the elements, here plus first element is plus, here minus, here plus, third element. The first element is plus, second element is minus, plus of this element into minor, minus of that element into minor, plus of that element into minor. Next problem. Using Laplace expansion, evaluate. This 2 open bracket means it is a determinant. So 1, 2, minus 3, 3, 4, 1, 1, minus 1, 6. So I am taking 1, 2, minus 3, 3, 4, 1, 1, minus 1, 6. So first row elements I am taking 1 into its minor. Minor means we have to delete row and column. 4, 6, minus 1, 4, 1, minus 1, 6. Next, minus 2 into, here 2 is there. So minus 2 into its minor. Delete row and column. 3, 1, 1, 6. Okay. Next, plus 3, minus 3 into, next row and plus, minus 3 into its minor. Minor means calculate 3, 4, 1, minus 1. So simplify. Simplifying. So 1 into its minor, minus 2 into its minor, plus minus 3 into its minor. Next, 1 into AD minus BC, 2 by 2 determinant, 4, 6, the 24, minus 1 into plus 1, minus 1, minus half, minus 1. So minus 2 into 18 minus 1, minus 3 into minus 3 minus 4, AD minus BC. 24 minus 1, 25, 1 into 25, 18 minus 1, 17, minus 2 into 17, minus 3 into minus 7. So 25 minus 34 plus 21, minus plus. So 46 minus 34, that is 12, is the determinant. Next problem. Find determinant of 1, 0, 0, 1, 1 plus x, 1, 1, 1, 1 plus y. So determinant, I am taking first row, means plus minus plus plus this element into its minor minus second element into its minor plus minus element into minor. So 1 into its minor means row column, resultant 1 plus x 1 1 1 plus y. Next second element 0 0 minus 0 into its minor, so row column 1 1 1 1 plus y. Next third element plus 0 into its minor, remove row and column 1 1 plus x 1 1. So 0 into something 0, 0 into something 0. It will two elements will cancel. Next, its determinant AD minus BC. So 1 plus x into 1 plus y. 1 into 1 means minus 1. Multiply 1 plus x, 1 into 1 1, 1 into y 1, x into 1 x, x into y xy minus 1. Minus 1 plus 1 cancel, x plus y plus xy is the determinant of the matrix. Next, using Laplace transform expansion, evaluate. Fourth problem. So 1. A determinant, open bracket means determinant, A H G H B F G F C, determinant matrix. So I am taking first row. First row means first one is the plus, next one is the minus, next one is the plus. Plus A into its minor, minus H into its minor, plus G into its minor. Okay, first row. So A into minor, we have to remove row and column, B F F C. Next, minus H into its minor, row and column, so H F G C. Okay. Plus G into its minor means row and column, H B G F. You have to simplify, AD minus BC. So A into BC minus F into F F square minus H into HC CH minus GF plus G into HF minus BG. So simplify. A into BC, ABC, A into F square minus AF square minus H into CH minus CH square minus minus plus FGH, G into HF plus FGH minus BG square, BG into BG square. So ABC first term, next FGS plus FGH, 2FGH. Next, A minus AF square minus BG square minus CH square, as it is. ABC plus 2FGH minus AF square minus BG square minus CH square is the answer. Next problem. ABC, BCA, CAB, determinant matrix. Same, it is also first row elements here, plus A into minor minus B into its minor plus into its minor. So A into minor, if you remove row and column, CAAB. Next, B minus B into its minor, so remove row and column, BACB. Next, third element C into plus C into its minor, BCC. So multiply AB AD minus BC. So A into BC minus A square minus B into B square minus AC plus C into AB minus C square. So multiply with ABC minus A into A square A cube minus B into B cube minus minus plus ABC. ABC C into C square, it is minus C cube. ABC plus ABC plus ABC, that is 3ABC minus A cube minus B cube minus C cube, remaining terms are same. Next problem means we have to remember, if you take the first row, first element plus A into its minor minus element minus B into its minor plus C into its minor, that is the determinant of the matrix. Okay. Next, solve for x. If determinant of 2, 3, 4 minus 4x minus 8, 5, 6, 7 equal to 0. Determinant value is given. In middle elements, one of the element is x, so we need to find equate to 0 and find out x value. What is the determinant? How to find? First row, I am taking first row. So 2 into its minor means delete this row and column, x minus 8, 6, 7. Next, 3 into minus 3 into its minor row and column, minus 4, minus 8, 5, 7. Next, third one, 4 plus 4 into its minor, minus 4x 5 6 equal to 0. So simplification, AD 2 into 7x, 4 into 6, 6 into 8, 48, minus of minus plus 7x plus 48, minus 3 into 4 is 7, 28, minus of minus means plus 40, plus 4 into 6 minus 24, minus 4 into 6 25, minus 5 into x minus 5x. So simplification, 7 into 2 14x, 48 into 2 96, minus 28 plus 40, what is 12. Okay, 12 3 is 36, minus 36. So minus 48, 4 into minus 24 minus 96, 4 into minus 5x minus 20x. Simplify, 14x plus 14x minus 20x, that is minus 6x. 96 cancel, plus and minus, minus 36 equal to 0. So minus 6x equal to 36. Minus becomes, it will comes plus. So x equal to minus 36 by 6, that is minus 6. 6 1 ja 6 6 ja. Okay, that is the answer. Next, so if 1 0 0 2 3 4 5 minus 6 x equal to 45, then what is the x value? So 1 into, I am taking first row elements, 1 into its minor means delete row and column, 3 4 minus 6x, minus 0 into its minor, we have to take delete row and column, minus 0 into row and column, 2 4 5x. Next, plus 0 into its minor means 2 3 5 minus 6. Okay, these two elements are zeros, means this total 0. 0 into something is 0, 0 into something is 0, equal to 5. 1 into AD minus BC, 3x minus of minus plus 6 into 4, 24. 3x plus 24 equal to 45. 3x equal to 45 minus 24. 45 minus 24 means 21. 3x equal to 21. X equal to 21 by 3. 3 will come, divides. That is 3 1 ja 3 7 ja 7 is the answer. Okay, it is the determinant of a matrix and problems. Means we have to take, if generally we will do this one. First row means first element is plus element into minor, minus element into minor, plus element into minor, plus minus plus. If you take second row, minus plus minus. If you take third row, plus minus plus. If you take columns also, this is the column. Okay, remember that generally we will do first row plus minus, first one is the plus, next one is the minus, next one is the plus. If it is a minus element is there, minus of minus, it will come as a plus. Okay, next, homework problems. Evaluate determinant of 1 2 3 4 5 6 7 8 9. First one. Next, determinant of PQR, RPQ, QRP. Next, determinant of 2 0 1 2 1 3 1 minus 1 0. Next, fourth one, determinant of cos theta sin theta 0 minus sin theta cos theta 0 0 0 1. Okay, 4 problems determined. Next, solve for x if determinant of 1 2 3 2 x 4 3 4 5 equal to 0. Next, second one, 1 0 1 2 x 3 1 3 2 equal to 3. Determinant value, find the x value. Okay. In this class we discussed about minor cofactor of a elements and determinant of a matrix. Mainly we have to remember, if you take the first row, the determinant is first element into its minor minus second element into its minor and plus third element into its minor. Okay, if you take this example 1 2 3, 1 into its minor, 1 into its minor minus 2 into its minor plus 3 into its minor. If you take this second row, it is minus plus minus will come. So minus 2 into its minor, minus 2 into its minor plus x into its minor plus 4 into its minus 4 into its minor. Any value is same. Generally we will do first row any time, that is plus 1 into its minor minus 2 into its minor plus 3 into its minor. Okay. And do the homework problems. If you have any doubts, please ask me, send me a message. Okay, thank you.